Hi everyone, we are talking about dilations today. So first, a little bit of vocabulary. A dilation is a transformation that changes the size of a figure, but not the shape. Okay? Changes the size, but not the shape. So the center of dilation is a fixed point in the plane about which all points are expanded or contracted. So a dilation can increase or decrease the size. The scale factor is the ratio of the distances from the center of dilation to some image point and the pre-image point. Okay, so we have some center of dilation, we have the image, and then the pre-image. So in this case, we have contracted. So our image got smaller. Okay. So the notation that we're going to use for a dilation centered at the origin is just a D. My scale factor is right here, n, and then my point, right? So a little bit more vocabulary. I have what's called a reduction, and you can probably guess. A reduction is a dilation that has a scale factor between 0 and 1. Whereas an enlargement has a scale factor that is greater than 1. Okay? So obviously, if we multiply by a fraction, we're going to get smaller, okay? And then if we multiply by a number greater than 1, we will increase in size. Okay, so first example, we have a dilation of our triangle XTR to give us our image, x prime, t prime, r prime. And first, we want to know, is this dilation an enlargement or a reduction? This is definitely an enlargement. Okay, now they want to know what is the scale factor of the dilation. So first, I need to, let's write it out. Okay, so I have some scale factor times my point t, which gave me 4. Okay. Now to go to t prime, all of a sudden we're at 12. Okay, so this distance from t to t prime is 8, so all together I'm at 12. So obviously I have increased by a factor of 3. Okay. So don't get tripped up by that. It's not 4 and 8, so you would think maybe 1/2, but nope. We increased by a factor of 3, so it went all the way to 12. Alright, moving on. So now I have a triangle PZG, okay, and they gave me the dilation rule here. So I have a scale factor of 2, and I am dilating my triangle. Okay, so they want to know first, what is the center of dilation, which they told me is, well, there's nothing there, right? So it's just going to be the origin. Later in these notes, we will discuss when the center is not the origin, okay, but for now, we'll just say it's the origin. Okay, the scale factor is given, it's 2, which is an enlargement. So I will say this is an enlargement by a factor of 2. Hey, now they want me to find the vertices of my image. Right, so this is my pre-image. They want me to find the vertices of my image. The nice thing is that it's super simple. We're just going to multiply everything by 2. Okay, so in this case, I have 0 times 2 and then negative 2 times 2. So my image will be 0, negative 4. 2 times 2, negative 1 times 2, so 4, negative 2. And then negative 2 times 2 and 1 times 2, so negative 4 and then 2. Okay. So if we wanted to graph this, let's use a different color. So now G is right here at 4, negative 2. P is here, and negative 4, positive 2. So Z is extended all the way to here. So my points pass through there, and this is my new shape. Okay, I have dilated my shape and enlarged it by a factor of 2. Alright, let's move on. So now for dilations not centered at the origin, we do have to include the origin here, which would be HK. This is very similar notation to a circle, or what you'll learn later in conics. Okay, but in this case, we just represent the origin using hk, and n is still the scale factor. But otherwise, really nothing's different. Okay, we just include the center of dilation there. Okay, so for our next example, we're given quadrilateral HJMN, and first they want us to write a coordinate rule that describes the dilation centered at J with a scale factor of 1/2. Okay, so the important part here is we know we're centered at J, we have a scale factor of 1/2. So the first thing I need to do is figure out where J is, right here, so -2, -4. Right, so that's going to be an important point for us. And they want us to write a coordinate rule, so I'm going to start with a D for dilation. I know that my scale factor is 1/2, my center is J, and I'm dilating quadrilateral HJMN. Okay, this is a reduction because my scale factor is between 0 and 1. Okay, now they want us to find the vertices of our image and then graph the image. Okay, so right here we're going to show our work, we're going to show the process, then write the new vertices here. So first I'm going to start off with just writing my scale factor. Let's use some colors here. So my scale factor is 1/2, okay, and my center is -2, -4. Okay, so again, we're centered at point J, so that's what I'm writing as my center. Okay, so just showing our work here. We have a little bit of a process, but it's not too bad, I promise. Okay, so something I know is I'm going to be multiplying everything by 1/2, so I'm actually going to write that in first. I'm going to be multiplying everything by 1/2. Alright. Next, I'm going to fill in my original vertex. So I have a -4 here. This will be -2. +2, 0. Okay, here I'm going to fill in the y value, so -2, -4, -2, and 0. Okay, now I'm going to apply what is happening here. So this is kind of straight up from the formula from above. What's going to end up happening is I'm going to add and subtract 2 because that's my center here. So I'm going to add 2, subtract 2 to all of my x values. I'm going to add and subtract 4 to all my y values. Okay. And so we do a little math, we get our new vertices, which are 3, -3, sorry, -3, -3, -2, -4, 0, 3, and -1, -2. Okay, so these are all of our new vertices for our image. So if we go ahead and graph these, -3, -3, so this is now H prime, that makes sense. Let's use a different color. Alright, so I'm at -3, -3 for H, which makes sense. I'm at -2, -4 for J. Notice how J is my center of dilation and it did not move. Okay, makes a lot of sense there. That's something that you're going to be looking for. Okay, I'm at 0, -3 for M. Sorry, I guess I didn't write the negative there. I'm at -3 for M. Okay, and then I am at -1, -2 for N, and so this is my new shape. Okay, so it just shrunk in towards point J. Alright, let's move on. Alright, so next example, a little bit of application. We have an apple and a seed, and we are looking at the apple seed under a magnifying glass, which has a scale factor of 7. So we're asked the actual length of the apple seed. So it looks like the seed, what they tell us is that we measure 1.75 inches. However, this has been magnified 7 times. Okay, so we're going to divide this by 7 and get 0.25 inches, and that will give us the actual length of the seed. And that's it. That is it. Super simple. Alright, let's do a few more examples. Alright, so we have triangle ABC below. We have a dilation rule of 1/2 of triangle ABC. So this is important to note. And I want to find the vertices of my image and then graph it. Okay, so my pre-image has vertices of 2, 4, 6, 2, and 10, 6. Okay, my image is just multiplied by 1/2. Okay, so 2 times 1/2 is 1. I'll end up with 2. This will be 3, 1. This will be 5, 3. Okay, so let's give this a graph. So we're at 1, 2 for A. Again, let's use a different color. So we're at 1, 2 for A. We're at 3, 1 for B, and 5, 3 for C. So here is our new shape. Right there. Alright, so let's keep going. So we have triangle XYZ below, and we want to use this rule right here. So 3/2 and then centered at Z. Okay, so we're centered right here. We want to determine the vertices of my image and then graph the image. Okay, so first things that I note are this is going to be an enlargement because I am multiplying by something greater than 1. My scale factor is greater than 1. I'm centered at Z, so I know that my new vertex at Z will not change. Okay, I know that right off the bat, so I know that this will remain 2, 3. I know that right off the bat. Okay, so let's talk through some process again. Let's use some colors here. So I am multiplying everything by a scale factor of 3/2. Okay, and my center is at 2, 3. Alright, so again, we're just going to set up my original vertices 0, 1, 1, 0, 2, 3. Okay, so I am going to have some points here. Okay, I'm going to first be multiplying everything by 3/2. I know that right off the bat. Okay, I'm going to go ahead and plug in my point, which in this case is 0. This case is 1. This case is 2. Right here I'm plugging in 1, 0, and 3. Okay, we're going to add and subtract, so I'm going to be subtracting 2 and then adding 2. And then we're going to do the same thing to my y values, so we're going to subtract and add 3. Okay, and this will give us our new vertices. So if we do a little bit of mental math, it will end up getting negative 1, 0, and then we'll end up with a, let's see, that would be 0.5 and then a negative 1.5, looks like. Alright, so let's give this a graph. So I'm starting at negative 1, 0. So this is my new x. My y is at 1.5 negative, so about right here is my new y. And then my z, again, will not change because that's my center of dilation. So we connect, and it's my new image. Alright, so again, your homework is below. If you have any questions, let me know, and have a great rest of your day.